In this tutorial, I will show you how to find the domain and the range of a quadratic function, and we'll do 4 examples. Here's the first one. We have negative parentheses x plus 1 squared plus 3. So first, for the domain of any quadratic function, or in fact any polynomial function, it's just going to be from negative infinity to positive infinity. Because we don't have x on the bottom and we don't have x in the square root, and we are not dealing with logarithms, and we have no worries. So just negative infinity to positive infinity. For the range of a quadratic function, we have to find its vertex first. So note that this right here is in the vertex form. When we have the equation in the form of ax minus h squared plus k, there are 2 things you have to know. First, the a will tell you if the graph opens up or down. So I will just give you guys something like this. This is the situation where a is positive, and then if we have the a is negative, it's going to go like this. And the vertex is precisely at h, k, here or here. And of course, you can move the parabola anywhere. Sometimes you might not have the x-intercept, but let's take a look right here. Be careful though. We have x plus 1. We actually have to do the opposite because here it's x minus h. So the vertex of the parabola is actually at negative 1, 3. All right? And then because the a value here is negative, so we're looking at the open down situation. So a less than 0, the graph opens down. So if you come up with the graph right here real quick, negative 1, 3 is somewhere right here. And then the graph opens down, so you can make a quick sketch like this. And you will be able to see that if you look for all the possible y values, it goes from negative infinity all the way to 3 only. So we go from negative infinity to 3, including the 3 though. So just like that. Remember, domain is all the possible x values, and since there's no restrictions, we have no worries. We can use any real number for x. So that's the domain. And for the range, it's all the possible y values, because right here is 3, and it keeps going down. So the smallest y value is negative infinity, and the biggest one is 3, including the 3. Now let's take a look at another example. Okay, now for this one, the domain is again negative infinity to positive infinity. And for the range, we need the vertex first. So this right here is minus 2, but you do the opposite, so it's 2. And then this right here is just negative 12. And then here the a value is 4, which is greater than 0. So the graph opens up. So if you make a quick sketch, let's say here is 2 and here is negative 12. Here's the vertex, and we just have to, go like this. So the lowest y value is negative 12, including that, and then it keeps going up. So we go to positive infinity, and that will be the range. Now let's take a look at what if the quadratic equation is in the standard form. For this one, the domain is still negative infinity to positive infinity. Now for the range, once again we have to get the vertex first. And when we have a quadratic equation in the standard form, we have to find out the vertex first by using the vertex formula. So here's the deal. When we have f of x is equal to ax squared plus bx plus c, we know the vertex is going to be at x equals negative b over 2a. And once we have the x value of the vertex, you can plug back into the function to find out the y value. And for this one, our vertex will be at x equals negative b, which is the 5 right here, over 2 times a, and a is 1 right here. So we have negative 5 over 2. Now we are going to be plugging this into this and that x. So we get y is equal to negative 5 over 2 squared plus 5 times negative 5 over 2, and then plus 11. Okay, work this out. Negative 5 over 2 squared, we just do negative 5 over 2 times negative 5 over 2, we get positive 25 over 4. This times that, in fact, we get negative 25 over 2, and then plus 11. Now we have to combine these fractions. Here we have 4, so for this fraction, I need to multiply the bottom and the top by 2. And then for the 11, which is the same as 11 over 1, we multiply the top and bottom by 4. So we are looking at 25 over 4 minus 50 over 4, and then plus 44 over 4. Combine the tops. This right here will be negative 25, and then plus 44, we get positive 19, and that's over 4. Alright, that said, we know that the vertex is going to be at negative 5 over 2, comma, 19 over 4. And then because our A value is 1, which is positive, that means our parabola opens up. So if you make a quick sketch right here, let's say our negative 5 over 2 is right here, and 19 over 4, let's say, is right here. So here is our vertex, and the parabola will go up like this. And that means our range, we have the smallest y value here, 19 over 4, and we go all the way to infinity, including the 19 over 4, but never including infinity. Yep. So again, domain, negative infinity to positive infinity. For the range, this is in the standard form. So remember, the vertex is going to be at the x value. X equals negative b over 2a. B is 8, so we have negative 8. A is negative 2, so that will be 2 times negative 2. On the top, we get negative 8. On the bottom, we get negative 4, so we get positive 2. And then plugging this into all the x's, we get a y. That will be negative 2 times this 2 squared plus 8 times 2, and then minus 3. So work this out first. 2 times 2 is 4, times negative 2 is negative 8, and then that's plus 16, and then minus 3. That is positive 8 minus 3, so we get 5. So the vertex is at 2, 5. And then our A value here is negative 2. So because A is less than 0, the graph will open down. Okay, let's say 2 is here and 5 is here. So here is our vertex, and the graph will open down. So it will look something like this. And in fact, if x is equal to 0, the y is negative 3. So the y-intercept is somewhere at right here. So it's around negative 3 for the y. But for the range, the smallest y value is technically negative infinity, right? Keeps going all the way down. And then you go up to 5 right here, including the 5. Yep, so that's how you do it. If you have any other questions, feel free to leave a comment down below and let me know. That's it.